Hi everybody, welcome. So hopefully in the right session. This is about Team Foundation Server and using Git inside the Team Foundation Server. I'm cheating a little bit today. This evening we'll be doing there's a small conference happening over on the other side of the world called Build. Don't know if you've heard about it. And they're going to be showing the on-premise version of Team Foundation Server there. So I thought, rather than letting those guys see things first, we would let you see the on-premise version of TFS running Git first here, rather than, yeah, here we go. Cool, okay. So as long as everybody's cool with that. Thank you. So everything I'm going to show you here today obviously does work in the Team Foundation service as well, and has been available in the Team Foundation service since January. But I'm going to go show you the new shiny bits just because I can, and I hopefully won't get in trouble because by the time the video's out, the build stuff will already be done. Great. So my name is Martin Woodward, or if you want to email me, it's martinwoo@microsoft.com. That's how you abuse me on Twitter. And if this is really exciting to you, you can come along and listen to the Radio TFS podcast. Myself and some of my friends do a podcast every couple of weeks about Team Foundation Server. Very exciting, obviously, if you're into TFS. We'll actually be doing a live one on Thursday with me reporting here from TechEd and Greg reporting from the Build conference. So it should be good. I am I helped write a couple of books, to say, not that makes me an expert. It just, means I know some clever people. But those books are about 2012 and, blah, blah, all good bookshops. They're down in the store, whatever. Okay, they make me do that. Right, I'm a program manager on the Visual Studio team. So I work actually on Team Foundation Server. And I'm in Scrum terms, I'm what's called a product owner. So I look after a little bit of the TFS. The bit I look after is the Git stuff and the Eclipse tools and the cross-platform tools and things like that. So that's what I do. My name, program manager, is a strange one because I don't really program anymore. Most of the code I do right now, the devs try and take out as quickly as they can. And I don't actually manage any people. I manage the program, so I mostly seem to just delete email, really, and come along to see you guys, so that's good. I live in sunny Northern Ireland over there, so I'm actually fairly local, not too far away. And I work from home. I'm a remote member of the main Visual Studio team, so I sit at home in my little field in the middle of rural Northern Ireland. It does rain all the time in Northern Ireland, so we get lots of rainbows. But it's a beautiful part of the world. And that's where I sit, and that's sort of a view out of my office. It's great. I can watch the kids playing. A very, very lucky job. Microsoft did actually give me an office in the Belfast office in Northern Ireland. I don't go there for two reasons. One reason is because it's a sales office, so I'd be the only developer in a room full of sales guys, and that doesn't sound fun to me. But the other reason is, well, there you go. That's where my office is. And as you can see, it's a little bit not very glamorous. That there is exactly where my desk is, just looking over onto this warship. It's the oldest warship in the world, believe it or not. And yeah, it's an interesting place, very desolate industrial place. This here, anyone watch Game of Thrones, actually? That's where Game of Thrones is filmed, believe it or not. So there you go. And that's the Titanic Studios, and that's the Titanic Museum. Don't let this worry you. This is where the Git stuff and Visual Studio is built, and this is where they built the Titanic, this hole here. So it was fine when we last touched it, is what we like to say, so it'll be okay. Most of my team live in North Carolina. They're actually probably about 60% of my team working on the Git and cross-platform tools live there in North Carolina. And then we have people who are like me, remote, spread across the world. We've got people in China. We've got people in Australia. We've got people in Philadelphia and Chicago and Cambridge, Massachusetts, and all over the world, spread around. And then the other half of the Team Foundation Server team, they're based over in Washington State, in Redmond. And it used to be until recently that's where our Team Foundation Server lived as well, in Building 42 in Redmond, if you're ever there. But it's not Now, my Team Foundation server is in the cloud because we use the cloud service. So that's where my TFS server lives. For us, the cloud really means, a car park in Chicago somewhere, where in a shipping container. But, it's in the cloud, so it sounds more glamorous that way. But the teams are spread out, and they're spread out across the world, across multiple time zones. The advantage of that is that as the Team Foundation server team itself is completely, spread out across the world, as we've been building TFS, we've always built it to work really well in an internet scale environment. So it works really well over internet networks, high latency, low bandwidth networks. It works very well there. And we've always worked quite distributed. So both Team Foundation version control and then distributed version control, they still work quite well over wide area networks. That's good. That's because we use it every day. So I had a great question down at the booth yesterday. One guy asked me, so I've heard of ALM and I've heard of TFS. What do these words mean? And, what's what? And I was trying to explain it to him. So I put this picture in, which is basically Team Foundation server or service is the thing in the middle which provides the core services for you to manage your application. So we provide a set of services such as work item tracking services, so managing of defects, bugs, tasks, stories, product backlog items, that sort of thing. We provide source control services, and then we have build and deployment, feedback, test, lab management, planning. Actually, far too many services to put on a deck nowadays, but it looked pretty, so I took this one from the marketing guys. And then around that, we have the process, and then we have the ways that you can come in and talk to the core services that are inside TFS. So we've always had this integrated ALM platform, and the key thing about Team Foundation Server is it is very tightly integrated. So the source control is integrated with work items, they're integrated with build, they're integrated with test. It's all built in, and it's all that data is stored in a single SQL Server database and backed up in your enterprise, and all access control in the on-premise version of TFS is controlled via Active Directory. So you control using standard Windows login who can access your server. You back up your data to a single database. It's all good. Now, in source control, there are when we look at the source control market as it exists, just in the world, there are 3 modes of operation today that you see. The first mode of operation is the one. So who here? Quick question: who uses? Who's on TFS? Who's using TFS today? Okay, there we go. Wow, fantastic. Who is using TFS 2010 today? Who is using TFS 2012 today? Okay, that's pretty cool. Great. Who's using TFS 2013 today? Hey, there we go. That's good. Ryan, not long now. Actually, who uses the Team Foundation service? Okay, well, you are all using TFS 2013 today, so that's good. That's good to know. And you've been using it for a while, so thank you very much. So there are 3 modes of operation: check in, check out. If you're using TFS 2010, or you've been used to TFS until now, this is the only mode of source control that you know is check in, check out source control. This is all that TFS 2010 provides. And that's the standard source control you've known, as you've been growing up. Basically, when you get the files locally, they're read-only. When you want to edit the file, you have to explicitly check out the file. You have to tell the server, hey, I'm going to edit the file. The server says yes or no. You edit the file. You then check it back in to the server, and then that's it shared with your team. And that's how source control works today for the TFS 2010 people. This is great in that it scales to massive code bases. Inside the Visual Studio team, we use traditional check-in, check-out source control against TFVC, and we have, gigabytes of code in an average working set. And, which when you do a get from disk, you have gigabytes of code there with hundreds of thousands, millions of files. It's ridiculously big because we download all sorts of stuff we don't need to. It's amazing. So we have all that in our source code repository, and it scales really well. It scales to thousands of people using it at the same time, but more importantly, it scales to large integrated code bases. Another useful feature of centralized TFVC is that you have a fine level permission control. So you can control permissions down to the folder and file level. And in the check-in, check-out mode, you can even change the permission on a file and make it so you can't edit, or your team members can't edit a file, even when they already have it on their local machine. You tell them, no, you can't edit this file. You can read it, but you can't edit it, and you can't check it back in. So you've got much more granularity over permissions. And then because of the fact that you have to talk to the server every time you want to edit a file, every time you want to download a new copy of a file, you can get a lot of metrics from the server to tell you who's working on what at the current time, who has downloaded what versions, where the source code is on which machines, that sort of thing. So that's what check-in, check-out mode's good for. And if you want a fine level of control, a fine level of auditability, and you need scale for a very large integrated code base, this is the source control system for you. This will always be the source control system for you. We will always support this form of source control because we use it ourselves and we rely on it ourselves. Next, we have the edit commit mode. So check-in, check-out is called a TFS server workspace in TFS 2012, server workspaces. Edit commit mode is a TFS local workspace, is how that's represented. So the edit commit mode of source control, if people have come from, say, something like CVS or Subversion, they might be more familiar with edit commit. When you download the files locally, the files are now writable on your local disk. You can edit the files without having to check them out. There is no explicit checkout operation in a local workspace. You never have to check out the file. You just edit the files on your machine, and then when it comes to check them in, to share them with your team, you check in. And when you check in the code, the client code, so Visual Studio or Eclipse or whatever, the command line, it examines your current file system, compares it with a hash of all the files that you last downloaded from TFS, that it stores locally in a special secret folder, and then says to the server, hey, I've edited these 20 files. I want to check them in now, please. But to do that, it has to scan the entire local disk first to see which files you've edited. So every time you go, hey, can I check in? It scans the disk and sees which files you've edited. So this is great for offline mode, obviously, because there's no longer any explicit checkout code. So you no longer have to talk to the server when you want to edit a file. It's also really useful if you're editing outside of Visual Studio, because when you're inside Visual Studio using a check-in, check-out, using server workspaces, you actually, this Visual Studio or Eclipse will just check out the file for you. So you never really notice you're having to check out files and do that explicit checkout operation. It goes away. But if you're trying to edit in Notepad, or if you're trying to edit in Sublime Text or, Access or whatever, some tool outside of Visual Studio, then you have to remember to explicitly check out the file. And it's always a pain. You always forget, and you have to go, oh, it's read-only, blah, blah, blah. And certain tools that you run that don't expect files to be read-only, like sometimes you get tools that are part of the build process in particular, or tools that are, like a vendor plugin or something like that, might not expect files to be read-only. They get confused when they can't edit a file and sometimes give you strange errors that don't make sense. And so with a local workspace, all those things go away. There's a few other things that go away as well, and I'll show you that in a second. Local workspaces, they're great for They can handle decent-sized code bases, so say 100,000 files, no problem. It depends on the size of your local disk, on the speed, sorry, of your local disk. If you've got an SSD, if your local disk is very, very fast, then it can do that disk scan very, very quick. And so you can have, 200,000 files, you can have several 100,000 files, and it'd be fine. However, if you've got a laptop with a 5400 spinning Rust hard drive in, then you might only be able to get to, say, 100,000 files locally before you start to notice check-ins taking quite a long time, because it has to scan your source code. But I've worked on I worked on government projects for billions of pounds that ran for years, and the entire source code fit on a floppy disk or a CD-ROM drive. So the odds of you needing code bases this large are normally quite small. Normally the people that do have them are people like Microsoft. It's not usual to have really big code bases. So for most people, a local workspace is a nice balance between control and performance. So that's a good one to consider. And it's actually the default in TFS 2012. It also, because there's no explicit checkout, you no longer get that communication between client and server when you're about to edit a file. So if I start editing a file and Anthony here starts editing a file, the server doesn't know that we're both editing the file at the same time. So the server can't warn me that Anthony is also editing it. And we only find out when we go to check in and one of us has to resolve the merge. Whereas check in, check out, we can still both edit the same file at the same time, but the Visual Studio can pop up a little warning saying, hey, Anthony's already editing this file. You might want to consider doing something, you might want to give him a call and see what he's doing on it. Okay, so let's go quickly show you, for the people who haven't used TFS 2012, let's go quickly show you local workspaces and some of the cool things, and then we'll jump back and talk about the next thing. So, there we go. Right, great. So this is TFS 2013, the on-premise version. You can see here, I'm talking to TFS 2013. If you've been using an account at tfs.visualstudio.com, you notice this looks very familiar to you, because this is basically, we've been shipping versions every 3 weeks until we got to the 2013 release. So it's basically the same code you're running out in the service. We've done a lot of improvements since TFS 2012, and especially since TFS 2010. In a lot of things, there's colour and all sorts of stuff. But if I go over here into the code experience, we've actually got a really good, code browsing experience now. So I can go here into my main branch, browse through. I can go down to program.cs. I get a little, data here telling me who last edited it. I can go look at the file. I get syntax highlighting. It's all cool. It's, this is source control in modern TFS. Now, if I, in Visual Studio, if I come in here, I am I'm attached to my Fabricam Fiber project, and if I go to Source Control Explorer and actually go to that main branch again, we can see there it is, and I can click here. And if I look at my files, currently I have what's called a server workspace. So we see here, it says read-only. That's because it's a server workspace. The file is read-only. If I go into pending changes, I'm hoping it might give me a window, but I can show you a different way. It warns me that, hey, this is currently a server workspace. We've got this funky new feature in TFS 2012 and TFS 2013 called local workspaces. Do you want to learn more about them? Do you want to upgrade? And you can actually upgrade your server workspace to a local workspace just by clicking on that link. Or, if you want the hard way, which I'll show you because this is kind of hidden, and this is what you come to see is the hidden stuff in TechEd. If you go to Source Control Advanced Workspaces, Edit, and then press the Advanced button, look at that. There we go. Location Server currently. We can come in here and set that to local. Notice here we also have some stuff file time. It's set to current. If you want the file time to be the time at which you checked in the code into TFS, you want that to be the timestamp of the files locally, you can change that here as well. So there you go. So I'm going to set that to local. hit close, and that's going to convert my server workspace into a local workspace, he says, and it's done something, and I'm hoping that pop-up will go away. Let's see if it's worked. But we'll just right-click on here, and we'll do properties again, and look. So now that readme.txt is no longer read-only. It's writable. And if I actually edit a file in Notepad, so I can say, Hola, Madrid. There we go. That's about the extent of my Spanish, unfortunately. Save. I've saved that. I didn't have to explicitly check out that file, so that was quite cool. And if I go over to here, and what did I want to do? Oh, sorry, if I go to pending changes, we can actually see in the included changes area, you see readme.txt has automatically come up. So TFS has automatically detected that the readme file has changed. If I was to go back and, so I can check that in now, and I can say, changed comment. I can associate that with a work item. I'm just going to associate everything with work item 1, 2, 3 here just for speed. Check it in. So I've now checked that file in to version control, and it's always stayed writable locally, and I'm sharing it with my team. Now if I was to go back in, here you go, and let's edit this file again. So I'll now say, let's say, hello Madrid, hit Control S. It saves it, go over to here to Visual Studio. And I'm noticing it's not automatically refreshing, which is exciting. It normally does, so I might shut down Visual Studio and come back in again. Here we go. It's popped up. It says it's edited. And if I go back here and take this back to do a Control Z to get it back to how it was, Control S, and I'm going to hit refresh, which I shouldn't have to do normally, but there we go. And now I haven't got any pending changes, so it knows which files have changed. It also does some cool stuff. Have you ever had, TFS 2010 people especially, somebody saying, I'm doing get latest and it's not showing me the latest code. It's not doing something crazy. I have to do get specific, force, blah, blah, blah to get the code. Okay, what's happened there is somebody's edited the file locally and hasn't told TFS. And with a server workspace, you have to tell TFS about every single change you do locally. With a local workspace, you don't, because it's a local one. So if I come here, for example, I can show you a bunch of these types of things, but if I delete that folder, in a server workspace, if you were to do a get latest now, it would say, yep, all files up to date, and that folder would still not be there. Because as far as the server is concerned, you didn't tell the server you were deleting that folder, therefore that folder surely must be there. You wouldn't do something crazy like delete it outside of Visual Studio. That would be silly. With a local workspace, because it's local, if I right-click on here, do get latest version, and go back over here into Explorer, ta-da, hello world appears. Great. Okay. So for a lot of people, local workspaces are a nice low-friction way of doing version control with what's called a centralized version control system. So these two types of version control are centralized version control. You have a central repository, and you get a copy of the latest code locally, and then you check that code into TFS and share it with your team by checking it into the server. Now, when we looked around the industry, we saw a new type of version control called distributed version control. A distributed version control is interesting because it's distributed. So what does that mean? Dramatic pause. Distributed version control means that your repository, when you do a get or a clone operation, your entire repository is copied to your local machine. That sounds crazy at first for people using centralized version control, because they're like, what, my entire repository? I've got gigabytes in there. What do you mean entire repository? Well, first of all, a distributed version control system is very efficient at storing the repository and storing differences, so it's maybe not as big as you think. But it does download the entire source code of your system, including history, to your local machine. That's the key thing. It's source control and history, local. What does that give me? Well, that gives me a full offline experience. Not only can I edit locally without having to talk to a central server, I can even check in locally. I can commit locally and make a record of my changes locally without having to push my changes to the server. That's one thing. Another thing that distributed version control systems is, back with a local workspace, or with TFVC, we were in here. You see the branches are in what's called path space, so you can actually see the branches exist as things in the main part of the repository. In a distributed version control system, we simplify that, and the branching model actually exists repository-wide. So when you create a new branch, you create a new copy, if you like, of the entire repository under a different name. So it's a much more simple branching model, but the simplicity means that it's easier to branch often, and people find it easier to understand because the source code stays in the same place. You just, flipping the branch that you're looking at. So you don't have to get copies of source code in different places on disk and things like that. Distributed version control is great for a few things. It's obviously great if you're working with an open source project that's already in a DVCS, because you can pull down that source code in your open source project and have the full history there. If you want to update the versions of this open source library that you have, you might have made some changes to it yourself that you haven't contributed to the upstream project, you naughty boys, but maybe you did, and it's fine. I have a real job too. I sometimes can't contribute everything I do, but luckily Microsoft are very good at letting us contribute code to open source projects. Not every company is. So fine, you've made some changes. You want to merge your changes with changes that have happened in the upstream project. If you've kept the history, it makes it easier to do that because you've stored the base location where the two projects were the same. You've stored your changes to that project, and over in the open source project, they've stored their changes to the open source project. So you can pull down their changes and merge them with yours, and that's a bit easier if you've stored the history with the open source project. So that's good. It's obviously great for highly distributed teams because they can do full check-ins while they're offline. They can have entire copies of the repository so they can query history and see what happened and annotate and do things like that without having to talk to a server. Where it's a killer feature in the enterprise is actually working with offshore teams and working in consultancies, where quite often the client wants to get a copy of the entire repository of source code with history. So using distributed version control, you can actually send them a copy of the entire repository with history, and they have it, and they can just take a copy of it and have it in their server, because history is now portable. So with distributed version control, for the first time in source control world, history is portable. And if you think about the problems you've had moving between version control systems in the past, it's always been because you wanted to keep that history. And you can't do that with centralized version control. It's a pain when you're trying to migrate centralized version control systems. With distributed version control systems, history comes with it for free. And so actually, distributed version control kind of spells the end of vendor locking into version control systems, which makes me happy as a developer, probably makes the sales guys unhappy, but there we go. So, history comes with you, which is great. So we had a look round. We realized quite early on, so DVCS has become a particularly big thing in probably the past 2 years. Definitely the last 5, but possibly the last 2 years, it started to take off in adoption. And more open source projects have been moving over to DVCS. It's been really interesting. So when we had a look round at the DVCS market, there are a couple of popular DVCS solutions, things like Mercurial, Plastic SCM, and then of course Git. Now what we found is today Git is by far the leading DVCS distributed version control tool in the market. The growth of Git is growing exponentially. It's still a long way from centralized version control, but it's growing exponentially. And more interestingly to us, all the other distributed version control tools like Mercurial and blah, blah, they all use the Git format, the Git repository format, as actually the standard for interchange between, because history comes with DVCS repositories. They use the Git format for moving the history around if you're trying to convert from one repository to another. So that was really interesting to us, because now any distributed version control tool that we as Microsoft were to build, we now have to make sure it works and is interoperable with Git. So that was interesting. So, okay, Git's important. We then looked, people like Azure and Facebook and Heroku and a bunch of others are starting to use Git as a deployment protocol. What does that mean? Remember I said Git's very good at transferring differences around the network. It only sends the differences between your repository and the one that's on the remote server. If you've already deployed a version of an ASP.NET website to a server by pushing it to a Git repository on that server, it's very efficient for you to push a new version of the repository to that server, and it only sends the files that have changed. And then the server can then use those to deploy those files out to the production servers, which is really interesting. And also it can use it to roll back in history and all sorts of good stuff. So it makes sense to use there. So again, now when we're looking at building a distributed version control tool, it was like, well, so it has to be compatible with Git, and it has to speak Git at the network layer. Huh, that's interesting. So, we ask around, and it's like, well, what should we do here? And we have a look at Git, and we see that it's got fabulous cross-platform support. Git was originally written by Linus Torvalds. It works really well on Linux. There's been a Mac port for a very, very long time. It works great on the Mac. There's built-in support in Xcode. There's built-in support into the Android Studio. This is interesting. The only criticism that that people weigh against Git, especially some of the mercurial guys, is the Git tooling on Windows sucks, is what they would say. The Git tooling could be improved. So we looked at this, and we were looking at building DVCS into TFS, and we thought, rather than build our own version control protocol from scratch, let's just fix Git. Let's just help Git work better on Windows. And I don't mean let's, create a fork of Git, a Microsoft implementation of Git, and make it run on really well on Windows, and make it, and make it only work slightly differently on Windows and not be the same. No. Let's work with the Git open source community. Let's actually contribute to the Git open source project and make Git work well on Windows, so that wherever people are using Git, if it's inside of Visual Studio, if it's inside of Eclipse, if it's inside of GitHub, if it's anywhere, let's make sure Git works really, really well on Windows, because, we quite like you to build nice software for Windows, so let's make sure that works. That makes a lot of sense. So we're actually working with the open source community on this, and we announced in January full Git support inside of Visual Studio and full integrated support inside of Team Foundation Server. So what do I mean by integrated fully? Well, you have Visual Studio and you have the server or the service. So client server. Over on the server, you have a project, which you already have today. It has a TFVC repository. Centralized version control works very differently to distributed version control. So you pick the repository at the project level because it controls your workflow. But over in TFS, the TFVC repository is fully integrated into work item tracking, builds, blah, 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 all that sort of stuff. Now, in Visual Studio, you have Team Explorer, which provides all the graphical interface. And then inside TFS, we built a proprietary .NET source control provider into Visual Studio. And then we built a .NET object model as part of the TFS SDK. And that's available to you to talk to, the object model. But it's all written in .NET and all talks to the service. It uses standard SOAP protocols, HTTP. Or HTTPS, and we also have another implementation of that object model. We have a .NET version and we have a Java version. The Java version we use to build the Eclipse integration, which I work on, and we also use the Java version to write a cross-platform command line client. So if you're running on the Mac and want to talk to Team Foundation version control, which actually a lot of game developers do, because TFVC is really good at handling binary files, then TFVC is great. And that all works great, and that's worked for ages for great. So now what we can do is we can create a second project, and we can create that with a Git repository. And we still get the same integrated services that TFS always provides. So we get work item tracking, we get builds, we get test case management, we get everything, all integrated, but integrated with a Git repository. Over in Visual Studio, underneath Team Explorer, we build a Git source control provider. But rather than building our own proprietary .NET API to talk to Git, we build on top of an open source project called libgit2 sharp and libgit2. Libgit2 is kind of the standard library for talking to Git inside of a long-running process. There is code in there from Linus Torvalds and Junio and all the people who are behind Git. So yeah, it's maintained by very cool people. And it's a great project, and we work with the project, and I'm actually one of the committers to the project, along with a few other guys in Microsoft, and a few other guys in GitHub, and a few other guys working around the industry. So we all contribute on this library, and that's what we actually use ourselves to talk to Git that lives in TFS. Now, by using that library, by using that library, it also, the same library talks to local Git repositories, any Git repository. There's no such thing as Microsoft Git, you know, it's just Git. So any local repository that's a Git repository it can talk to, and obviously it can talk to any remote Git repository, so Bitbucket, Stash, GitHub, whatever. It can just talk to those. It's just Git. Because it's just Git, all the third-party integrations obviously all just work in and talk to TFS as well, because it's just Git. It's just speaking Git over the network. And then finally, if you want to move code between TFVC and Git, we have a tool called GitTF, which is actually an open source project stored in Git on Coplex. And that allows you to move code between TFVC and Git or back again and flow code between the two. What we actually find, though, is code doesn't very often flow between the two after maybe you've migrated some code over. What we normally find is that people actually link work items between projects. So they might have, say, their iOS developers working in a Git repository inside of one team project, linking back to stories that exist in project one. And you can link work items across projects in the same account, the same project collection very easily. So that just works great and is fantastic. So that's what people do a lot. OK, so let's go play with the bits. Enough talk. So here we are inside Visual Studio. This is where I left it, inside of my Team Foundation version control repository. I'm going to press this new button here, Connect to Team Projects. Now, I'm showing you, again, I'm giving you a sneak peek. Hopefully I don't get into trouble. This is Visual Studio 2013 preview. If you want to get the Git support into Visual Studio 2012, then you install Update 3 or Update 2. Or whichever update is available when you're doing this. Yeah. And then you install the latest update, there you go, of Visual Studio. On top of that, you install the Git tools. You get the Git tools for Visual Studio Tools for Git, actually it's called. And that's an extension we publish in the gallery for Visual Studio 2012 customers. But for Visual Studio 2013, Git is just built in the box, in every version. If you install Visual Studio Web Express, you get Git support built in Visual Studio 13 out of the box, which is good news. So what I do is I'm going to go here, press this new button, which appears in Visual Studio 2012, but here I am in Visual Studio 2013. And this is the new Connect page. And we can see I've got a couple of team projects I'm associated with. One's a TFVC repository, and one's a Git repository. So I'm going to double-click on my Git repository, and notice what happens is it goes from talking to TFVC to talking to Git. So let's just do that again. just to show you, because I don't know if anyone's tried to change version control systems before inside Visual Studio. It can be a pain. You'd have to go to Tools, Options, blah, 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 and it's just painful. Nope, not anymore. You just go there, click on that, and now you're using Git inside of Visual Studio. Great. So you notice the first thing it says is you need to clone this repository to get started developing. With Git, you need to get the entire copy of the repository to your local file system before you can start developing on source code. You don't just pull one file or pull two files. You pull the entire repository. Okay? So you clone the repository down. We'll say clone. We're just going to hit the defaults because they seem sensible. And that's going to take a copy of that repository and download it over the network onto my local machine. Now you notice as soon as I did that, good, it worked, great. Demo gremlins haven't yet appeared. The first thing it did is it shows me in Visual Studio 2013, it shows me which solutions are inside of my Git repository. That's actually really cool because it makes it very easy to get to your solutions very quick. So I can just go open a solution, just double click on it, and it'll open the solution for me. It does the same with TFVC actually. It goes and shows you repositories which are available. So that's cool. Now, typically, because you download an entire repository when you're talking to Git, your repositories are smaller in scope and more modular than an entire TFS version control system. It's a normal, small contained, these are the solutions I need for my team to work on. It's much more typical to have one or two or three solutions per repository. No more than that, really. You don't have hundreds of solutions per repository, because then your repository would probably be too big and would take too long to download, and you wouldn't want that. So, and remember, you only need to download the repository once. Once you've got it locally, you can just copy it around your local disk if you want to, and you're only downloading differences from then on. You only do that clone operation the once. So I've opened Hello World, and I can go in, and just edit files just like we normally do. So I can come in here and, just start typing. So let's do the same change, and we'll say, hola, Madrid. There we go. There we are. And I'm going to hit save. And notice as soon as I hit save, we can see it's just Visual Studio Source Control. We see we've got a little check mark here saying I've edited the file locally. So before I do anything with that file, let's just hop over to Web Access. We can see here, inside of Web Access, I'm currently looking at my TFVC project. I'm going to switch over to my Git-based project, and we see it's the same interface, I have the same cool home page, I have the same work item tracking and build tabs and everything else. Just when I go to the Code tab, things look kind of the same, but slightly different. Over here, I have a switch, so I can switch branches. Because remember I said branches are now repository-wide. So rather than seeing my branches here appearing in the path space, when I go over to Git, I see my branches here applying to the whole repository, and I can just switch and go to different branches. Great. So I'm going to go to the master branch. And then inside of this branch, I can browse around. So let's go look at that project we downloaded. We'll go look at program.cs, and we can see there it is. And all the same cool stuff that you've been using before, like the history view is still all here. Let's have a look. The messages, the inline diff is still there. So I can go in, have a look at the contents of the commit if I want to. It's all just the same interface that you're used to and you'll train your users on just using Git version control. So I'm going to go back actually and go look at that file again, and I'm just going to quickly do a annotate or something. Let's have a quick look. Program.cs. Yeah, it's just all the same. So I can click on here and annotate that file. Great. All the same. So now, one thing I want to mention as well. Remember I said security and permissions. In TFVC, you manage your permissions at the folder level. So if I go over here and go to Fabric and Fiber, I can actually click on any folder or even a file. I click on that one solution file, go to security, and change the permissions on that single file. In Git, the permissions are actually managed at the repository level. So if I was to click on a file or a folder, let's just right-click there, I don't have a security option anymore. Security is actually only available at the repository-wide scope. Another way of getting to it is clicking on here and going to Manage Repositories, and that takes you to the admin screen where you can manage security. Now remember I mentioned that in Git, typically your repositories are smaller than maybe your entire team project section of your code is in TFVC. So what we allow is to have multiple repositories per team project. Because you might have multiple teams working on things, you might have a framework repository, you might store images in one repository to keep them separate from source in another repository, that sort of thing. So we allow you to create new repositories. So I'm just going to come in here and create a repository, and I'll give it a crazy name like that. And then, we learned our lesson from making rename team projects really hard and still haven't done. So we can at least rename a repository really easily. So we'll come in here and we'll say TechEd Europe. There we go. We'll just rename that repository. Great. And you see all my permissions here are managed at the repository level. Fantastic. OK. So the next thing I want to do is let's go back into Visual Studio, and we can see here we're editing this file. So now we want to check this file in. So if we go over to Team Explorer and we look at changes, this is a bit like the pending changes experience in TFVC. We have the changes window, and we can see, just like you expect, there is the program.cs file. I can still associate this with work item 123 again, like I did before. And I can add a commit message, so I'll say localize, kinda. There we go. And commit that. Now, I've committed that locally. I haven't talked to the server yet. So if I go to my local commits, I can actually see I have one outgoing commit called localize, kinda. If I go back to here and I add a change, so say add comment, Control S, I go back to changes and I'm going to commit it, add some comments, I can hit that, I can commit that. I can then maybe jump out to Explorer, source, repos, Fabricam apps, sample, hello world. Jump over to Explorer. Let's say maybe edit this README file here. Let's tidy up some stuff. Save that. Go there. Go back to Visual Studio. Again, notice that the automatic refresh has stopped working. So we're going to hit refresh here, and I'm going to close Visual Studio and open it again because that should just be working normally. Oh no, readme.txt. Sorry, it already picked it up. It was already there. Okay, great. So change README in Notepad. I'm going to commit that locally. Cool. That's all good. Fantastic. So now if I go to my commits, we can see I've now got 3 commits locally. I want to now push those commits to the server. At the same time, I probably want to pull down any changes that have happened on the server while I was working on my code, and if there were conflicts, I probably want to have merged those conflicts. Now, Git on the command line, you can do that by doing, a git fetch, blah, 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 git merge, blah, blah, blah. You can do like a lot of commands, or you can do it here by clicking on the individual commands. But we've just got kind of a sync button, which does kind of a pull and then a push and merges it if it needs to and does what it needs to do. So we try and make it easy for people to use. So that's good. So now I've pushed those changes to the server. So if I go back up to here and view history on my Hello World project, we can see those 3 changes coming in one go. And if I go and click on Fix Up Message, we can see the individual commit is there, Fix Up Message. Great. Fabulous. OK. So the next thing I want to do is people like branching in distributed version control. Why do they like branching? Because it's really easy to branch. So if I'm here, one of the reasons, so I've got my branch. I'm going to go create a new branch. And I'm going to say feature A. So I'm going to go work on feature A now. In Git and in any DVCS, you can work on branches locally. You can create a branch without ever having to push it to the server. So you're here and you're working on your branch, and maybe you're working on your feature. So maybe your feature is to do something fabulously exciting, like add a bunch of comments into here. Whatever. There we go. Should have given a more exciting example. There we go. whatever. Great, so I maybe make some changes. I'm going to save that, and I can actually commit that locally as well. Sorry, I can commit that locally, and I can say change in feature A. Commit that. So I'm making these changes, and then maybe I'm going to edit some other files in the solution. So we'll go edit class 1, edit there on line 3 maybe, and we'll edit on line 2. We'll edit line, there we go. So we're just making some changes here. I'm going to go commit those. So you know, it's all the same stuff you're used to. It's just source control. So you come in here, more changes in feature A. Hit commit. Now, one of the things people really like about Git is it's very easy to switch branches. Watch this. So I'm here. There we go. I'm going to switch branches. So I'm in feature A. I'm going to go back to master now. Look at that. Feature A. He says. Feature A. Master. Notice none of those annoying, your solution has changed, panic, panic, sort of dialog boxes. No, what should I do? Give you 5 options, press the middle one dialog boxes. It just changes your files because that's what you're doing. You're switching branches. So that makes it really easy to go work on something, you know, in context. And then if somebody needs you to come fix something urgently, just switch back to the branch they need you to work on, fix it for them, push those changes up, go back to the branch you were working on, do your changes, merge them back in, and then push them up. So you would quite often, a common workflow would be to have branches locally that you never ever push to the server. They're just local. You'd only push them to the server if you needed a backup or if you were working on that branch with a colleague. So I'm going to work, I'm this feature A branch, let's go jump back to feature A. I could now go and merge that back in to, if I go up to here, sorry, click on the home page, branches. I could now merge that branch, feature A, into master very simply, and it would just work. But hey, where's the fun in that? I like a bit of conflict in my life. So let's go and cause some problems. So we notice here in feature A, we've added a comment down on there. And in fact, let's do it on one of these classes. We've edited line 3 on class 1. So let's go back to master. And we're going to edit line 3 again. So we'll say change in master. And we'll also do an edit here, another change. And then maybe I might go and I could edit some files elsewhere. So I've now made those changes in master, and I'm actually going to commit those. Sorry, I'm going to commit those locally. So I'm going to say make changes in master. Hit commit. Great. So now I've committed that stuff locally, and now I want to merge my master branch, my feature branch, into my master branch and see what happens. I'm going to get conflict, hopefully. That'd be cool. So let's go to, we'll go to, manage branches, and we'll say merge from feature A into master. Press the big bad merge button and see what happens. So it says merge has happened, but there have been some conflicts. Please resolve the conflicts. Now notice, I can still keep editing code inside of Visual Studio right now. We don't have any of those annoying modal dialog boxes that we used to pop up back in the 2008 days. We kind of learned our lesson there. So when we were building this from scratch, we tried to avoid any modal dialog boxes. We can just come in here and we can see, well, it's kind of done this. And if I go to class 2, it's merged those changes in. It's merged the changes into program, but it's got the conflict in class 1. So I can double click on class 1 and say, what's the problem? And I can do some stuff here. Or actually what I'm going to do is press the merge button. The merge button is going to bring up this shiny 3-way merge tool. And it's going to say, what do you want to do? Well, you know, I want that changed because that's not a conflict. I actually want that version there, changing master. But before I merge it, I want it to be editing master. You know, whatever you want to do. So you can do that, hit accept merge. And then that's now resolved that merge. So I've got no more conflicts to resolve. I go to commit, and we can see here it's ready to commit these files. So I can say merge branch feature A into main, into master, hit commit. Oh, and I could even associate that with work item 1, 2, 3 again, add, and then I hit commit. So that's now done the merge. Cool, hey? And if I go to my commits, I can then take all those changes, the feature A, blah, 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 and I can push those up to the server. So now if I go over to the server and look at the history of my Fabricam Maps project, notice I see the history of the entire file. So by default, I'm seeing all those changes I made inside feature A and the merge happen on those files because I pushed them all up. But I never pushed the feature A branch. So I can see all the changes and I can go browse the changes even though I didn't actually push that branch up. So that's cool. Yeah? Pretty neat. The next thing I wanted to show is that this is just Git. No voodoo. We've just gone and helped make Git work better on Windows. So, yes, sir. Sorry, I'll just get closer there. What the question was, what happens if you delete the feature A branch? That's a very good question. It would be fine, actually. Let me just check something. Manage branches, unpublished branches, feature A, hit delete, all good. Now, more interestingly, I could actually, how about this? Can you read that? Yeah? Okay. So I'm going to go into here and I'm going to go to Fabricam Apps, go into sample we're working in, wasn't it? Here we go. So this I'm in here is called Posh Git. It's basically a open source shell extension for PowerShell over the top of the Git command line. You know, the Git for Windows command line that the core Git project work on. So it's, if you like, a completely separate implementation of Git running on Windows. And here I can come in here and I can do things like, so here I am on master. What happens if we deleted the branch? Well, what happens if I didn't know I could do deleting of the branch from the command line and I was from Visual Studio and I was doing everything from the command line? I could actually do the git checkout -b feature B, we'll call it, just so we know what we're doing. Feature B. That's going to create a new branch called feature B and switch me to it. So there we go. Notice Visual Studio, I didn't even have to press refresh. Visual Studio just picked up the fact I'm now working in feature B. That's pretty neat. I can come in here. If I go, I'm going to bring up my changes page and then go back to PowerShell. I'm going to say, I better not do vi, had a notepad, readme.txt, come in here, change from notepad, Control S, close that down. Notice now it's there in the included changes. I could do a git commit here if I wanted to. I could do, let's do another thing. Let's like add a file. Notepad, readme3.txt. Yeah, blah, 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 blah. Hit save. There we go. And it's down here, seeing it already. Git over here shows it already. I have ls. I can see it. I do the command to add it. Git, sorry, let's make this a bit bigger. Git add readme3.txt, hit return. It goes from untracked into included. So if you're using a different Git implementation on the same machine, they all just talk to each other and all just synchronize. Again, that's one of the advantages of actually being involved in the core Git project, is we can make magic like that happen. So we'll do that. We'll commit it locally from Visual Studio. In fact, we could even commit it from, let's do that for fun. Let's do it from the command line again. So I'll say git commit. Oh, wow, I'm going on Jimmy line, sorry. Git commit git commit minus m fix from command line for bug. Now, obviously, you can't do work item association here, so we allow you to do this. Just say #123, and that'll actually create a work item association with you. Oops, sorry. Did I mean git commit with 2 M's? Yes, I did. Why don't you just do that? So, there we go. So that's done the commit locally. You can see over here the commit's done locally. And then if I go over to commits, we can see that there it is, and I could push that up if I wanted to as well. So there are all my changes that I'm working on there. So they work hand in hand. Now, that's just obviously, working on something locally. Fine, maybe you don't believe me. Let's do some other stuff. So let's go over to here. If I look in my local Git repositories, I already have Git TF, which is an open source project on Coplex. I work on the libgit2 and libgit2 projects, which we distribute with Visual Studio. So they're actually hosted on GitHub. So I've got those locally. PoshGit is also hosted on GitHub, so I've got that. And let's just, for fun, let's just go in here, and we'll actually we'll go clone let's go clone if we want to. So from a completely different repository provider, if you like, let's go clone that, bring that locally. Clone, and there we go. And I can actually do, from Visual Studio, do a clone from GitHub or from Bitbucket or from anywhere. And interestingly, we've worked with the GitHub guys and done things like GitHub for Windows, which is a Windows client which the GitHub guys build. That'll actually stick entries automatically into the registry that Visual Studio uses, so that when you do a clone from GitHub for Windows, it pops up automatically inside Visual Studio. And we're working with all the partners we can to try and make sure that's nice and smooth. So there we go. Great. It's just Git. Really. It's just Git. So this is me inside Visual Studio. I'm actually kind of a bit of a Unix guy, as you tell. I type ls and vi and stuff like that. This is where I normally like to live, over here in the terminal. So a nice old school terminal as well. So what I want to do is I want to work on the command line and do things like git pull origin to actually go pull down my changes. Sorry. PWD. I spelt it wrong. There we go. Git pull origin. There we go. So I'm actually going to take my changes from that we've been working on over in TF, that we pushed up to TFS, and I'm going to pull them down locally onto my Unix machine. This is actually a Mac machine I'm running here with a fancy console. So there we go. You've got nice ASCII command, ASCII art for TFS, but it's just Git. So you can come in and it's done those changes locally. So that's great. If I do ls, go into hello world, we can see there's that readme file we had earlier. So I can do, readme.txt. There we go. I can do vi on readme.txt. And I can, let's add a work item, make a change from vi. There we are. Git commit -a -m change from vi. There we go. Git push origin master. Now, as a Unix guy, that makes me incredibly happy, because all the stuff I know about Git and can use with Git, it just all works. It just happens that I'm accidentally doing things against, it's now all being backed up in the same SQL database and being shared in the same repository as my entire team. If I want to go into my web, I could have even done, associated with a work item, just like I did over in the command line of Windows by doing #123. If I go over into a web browser, again, any web browser, so Safari or Chrome or whatever, running on different operating systems, I can come in here and actually go browse my changes. And did I do a push? I did. Yep, change from vi, and I can see my commit coming in here from somewhere else. Great. It all just works, and I can obviously go look at builds and work items and do all the same sort of stuff. If I want to drag some stuff around on my backlog, let's even do that. It's obviously all just works wherever you are. It's just, it's a web. Duh. Kind of just works. Okay, so but it's just Git in TFS. Yes, sir.
How does this work with build, TFS build?
The question was, how does this work with TFS builds? I'll show you in a second. The question was, what about authentication? The authentication from Linux. The authentication works using BASIC over HTTPS. It uses HTTP, not SSH. So it's the basic auth over HTTPS is how it typically works. And that's how you would authenticate to some other Git repositories as well. Okay. So I'd actually cached my credentials locally here, and that's why you didn't see me type my username and password in. It would prompt them. But the credentials you enter are if you're talking to on-premise TFS, it's your, and this is a great question. If you're talking to your on-premise TFS, it's your, username and password, your domain username and password. If you're talking to the service, you actually set up alternate credentials. So you can use basic auth to the service because the service is controlled by Live ID. I'll show you that quickly in a second. I'll bring that up while I'm covering some recap. Good question. And then obviously as well, it's just Git. So if I go over here into Xcode, and I'm a bit frightened of Objective-C, so I'm just going to make some changes over here. Whatever, I'm not going to do anything. I don't even do the message. I'll save that. Notice Xcode has built-in Git integration into it. So there we go. There's modified. I can do now file, source control, commit. I can commit that locally. Fix from Xcode for fix for Xcode for I want to do pound, but it's not working anyway. Fix for Xcode for 123. Here we are. Fix for Xcode. Commit file. Great. And then I'm going to do Xcode file source control push, and I can push those changes up to TFS. It's loading my remotes from my server. Which branch do you want to push it into? I want to push it into Origin Master. Off we go. And that's that change gone from Xcode all the way up. Right then. You're asking about builds. That's great. Well, that's pushing the changes. There we go. It's finished. Let's just go create a build quickly. So the build stuff is exactly where you would expect to see it, here in builds. And in fact, that push I just did has gone and triggered a CI build that I'd already set up. But let's just create a new one for you, as we've got a few minutes. So I'll come in here, and I'll say TechEd Europe as my build definition. And this is all the same stuff you're used to doing with TFVC builds. Now, obviously, if you didn't want to use TFVC builds and you had a different build server you wanted to use that knew how to speak Git, this is just Git inside TFS, so you could just use another build server if you wanted. But obviously, TFS now has full Git integration, so we'll do a CI build, or let's do a scheduled build as we can. Source control. Now, get sources from a TFS Git repository might be one option. Maybe you don't want to get them from TFS. Maybe you want to get them from somewhere else. You can do that as well if you want to. But no, I would like to get them from my TFS repository. So there you go. Just basically include everything. I want to use that build controller. What do you want to build? I want to build my Hello World solution. Great, that looks good. Hit save. So it's just build as you know it, basically. I'm going to right-click on here, do QNew build. Off it goes. And while that's running, I can actually jump in here and look at one of these CI builds I ran earlier, because I had it set up. And you can see it's just all integrated, and it's all hooked in. It hooks into the commits that have come in. There you go, that was that commit from Xcode. It's because I don't currently have that repository active. I need to switch to it. I could do, but I can go in here in the service. I could go into the web, because I was doing it from there, going here. There we go, look at the commit there as well. So it's all linked together, just as you would expect to see. Okay. One thing I wanted to show was very important to me. Obviously, I've got Visual Studio Ultimate installed here because I work for Microsoft and I get it for free, so that's great. But one of the things I was very proud that there you go, that TechEd build finished successfully. Great. One of the things I was very proud of is that we do have it in Express. So now when you go to File, New Project, and you're doing a new, whatever, console application one, great. Add to source control is an option in Express. You click it. You get two options. Do you want to use TFS or Git? You can say Git. You're now using source control. So we'll just say, let's go to changes. So even without a server, I am happily here. Yeah, save. I can use source control from day one of using Visual Studio. I don't even need a server. I can just do that. Here we go. I'm just committing locally, making some changes, and they're all local. And so I can go look at them. And I have my history of changes. Now, when it comes to the time I want to publish my changes to a remote Git repository, you can do that. And again, if you want to push them to a repository on TFS, you just go to code. I'm going to pick that repository we created earlier, TechEd Europe, and I'm just going to go grab the URL out of here, Control-C, go over here, go there, hit publish, there we go. And that's going to go publish my changes, hopefully. Okay, wow, that's interesting. Okay, there we go. That's published them up. So let's now jump into that repository. console application 1, there we go. And yeah, we could just do some stuff with it if we wanted to. So rather than do main, what we could do, if we wanted to be really clever, and I've got 5 minutes left, so let's do this. Remember I said the Git code is actually it's the library is an open source library we're using. We actually publish our changes into the upstream open source library before we bundle them into Visual Studio. So that it's all, because that's where we take our builds from the upstream open source library. It's open source. That's what you do. So if I come in here, I can actually come in and add that library into the same library, libgit2sharp. I could add that into one of my projects. So if I wanted to write some code locally that used libgit2, that used Git, I can go use the same library that we're using and that we've helped develop and test and so on. I can just go do that, and using NuGet, just pull that into my project, and I can just start, and then I can say, whatever, using libgit2sharp, great, and then I can, because I'm a cheat, I can go now over to my desktop and don't really want you to watch me type all day. I can just write some code, and I'll copy paste some code from my blog, woodwardweb.com. Oops, Control Z, here we go, I want to do it there. Control V. So we go here, and so basically what I'm doing here is I'm getting hold of a repository. The repository I'm getting hold of is actually my local version of libgit2sharp. I thought it'd be really meta, so I'm looking at my local copy of it. I'm going to go get the latest commit, and then I'm going to go and get the author and the name out of the latest commit on my head branch. So head is the branch you're working on, and then tip is the latest version of that, and then go look at the author. I can then go see what files are in there, and then I can diff a couple of commits. It's really easy. It's just .NET. It's a .NET API that sits on top of libgit2, which is a C engine, which again we contribute to, which is this cross-platform portable Git library, which we've also helped do the .NET wrapper for. So there we go, and I'll hit save, and I'll do debug, start without debugging. And you can see it's really easy to actually code against a local Git repository as well, using .NET, and it's very simple. You can use the same libraries we do, and interestingly, because it's open source, you can just redistribute that library, and you don't have to worry about installing the TFS SDK, which probably makes it a lot easier for everybody. So yeah, there we go. That's the future, isn't it, I guess? So with that, if I jump back to slides. And now, actually, Team Foundation service. I was going to talk about the service, but before I wanted to give you a sneak preview. While I've got time, let's jump to tfs.visualstudio.com. If you go to tfs.visualstudio.com, if you ever want the latest build of TFS to play with, or if you want your team to be working in the cloud, then you can come here and get an account for free. I've got an account for free, so if I go to mine, I got it quite early, so mine's called martin.visualstudio.com, because one of the perks of working for the team, you get to sandbag the great names. So I'll jump in here. I'll just log in. What I wanted to show you, I'm currently logged in here with Live ID, and I can't actually talk and type my password at the same time. So excuse me. There we go. So I'm just logging in here. Now, if I want to use the command line from Git and places like that to talk to the service, I actually have to go into my profile and enable what's called alternate credentials. And in here, you can set a username and password that you might want to use for basic authentication. Great. I'm glad I answered that question. Thanks. So, yeah, Team Foundation service is free for 5 users. Go use it now. Go sign up now. Even if you just use it to play with, it's great. And it obviously works with all versions of Visual Studio and so on and so forth. And it's good stuff. So the key thing is we provide choice. Whichever is the right workflow for your team, you can use inside TFS, and you can get the benefits of TFS in terms of all the integration, or the builds, or the work tracking, or the database backups, or the Active Directory user authentication, all that stuff. Very easy install nowadays on Windows, all that stuff, and you get to choose which version control workflow you want. TFS is not just TFVC server workspaces. You can pick whichever version control workflow you want. And you can obviously pick your choice of development process, Scrum, Agile. We didn't really talk much about work items today, but you can pick those. And you can pick your choice of platforms. You can edit on whatever platform you need to and collaborate using Team Foundation Server. It just works. Okay, with that, we've had some questions going. I'm going to go down to the booth area. So if people want to ask questions, come follow me down there. Otherwise, send me an email, and you can come catch them, Martin Wu. And please remember to fill out your evals. And one last thing, I'm going to be talking about the service a lot more on Friday, Dev B215. And then there's also an instructor-led lab on getting started with the service tomorrow, IL201, if you want to go play with that and sit with the lovely Anthony and get him to actually teach you through it and show you how to use the service. Okay, so thank you very much for your time. Let me put up a quick QR code so you can give an eval, because if I don't get more than 10, then I don't get to come back. So there you go. Right, thank you very much for your time.